Welcome to Probability, Chapter 10, Section 1. Our goal in this unit is to learn to find the probability of an event using the definition of probability. We have 8 vocabulary words. I would either have done those definitions prior to starting this video or do them afterwards by looking in the glossary of your textbook. And let's begin. An experiment is an activity which results are observed. Each individual observation is called a trial, and the results are called an outcome. Now, in a sample space, we record all the possible outcomes of an experiment. So an experiment could be flipping a coin. If you're flipping the coin just one time, that would be called a trial. The outcome would be the result, the heads or the tails. And in a sample space, we would record all the possible outcomes. So in this case, you get heads or tails. Those are the only possible outcomes from flipping a coin. Okay, if we have an experiment of rolling a number cube, actually doing it is called a trial. If we do it and the result is a 4, that is called the outcome. But in our sample space, we would list all the possible outcomes, the 1, 2, 3, 4, 5, and 6. Does that make sense? Okay. An experiment could be guessing the number of marbles in a jar. The trial would be the actual guessing, whereas the outcome would be the actual guesses. In the sample space, if we were going to list all the possible outcomes, it would be all the whole numbers. An event is a set of one or more outcomes. So an event is a set of outcomes. The probability of an event, written P parenthesis event parenthesis, is a number from 0. Probability of 0 means it's impossible. And the closer it gets to 0, the more unlikely it gets. To 1. 1 means it's a guarantee, it's certain. So the event is certain if it's a 1, and the closer it gets to 1 means the higher probability it's going to happen. This one's important. The probabilities of all the outcomes in the sample space will add up to 1. We'll use that to find other probabilities as we work along and to check ourselves. Okay, now I've talked about this, but let's repeat this one more time. These are probabilities. If the probability is 0 or 0%, it means it's never going to happen. The closer the probability gets to 1 makes it more likely to happen. And a probability of 1 means it's certain, it's going to happen. 1 changed into a decimal form is 100%. 3/4, 0.75, that's 75% chance of happening. 1/2, that's 0.5. You may have also seen this as 0.50, which, remember back, move the decimal over 2, that's 50% of it happening. 1/4, 25%, 25% chance of it happening. 25 hundredths, 25%. Okay, open your notebook and let's take a look at example 1. We have a basketball team has a 70% chance of winning. So the probability of winning, as I just stated, is 70%, which is, remember back to decimals, and you're going to move the decimal point over 2, it's 0.7% chance of happening. The probabilities, think back 2 slides, must add to, do you remember? That's correct, it must add to 1. So, the basketball team has a 70% chance of winning. The chance of not winning, the probability of losing, is going to be 1 minus 0.7, which is 0.3, 3/10, which is 30%. You can also think of this as 100% chance minus 70% is going to equal 30%. So the probability of losing is 30%. Probability of winning was 70%. To stress this again, 70 plus 30 equals 100%. 0.7 plus 0.3 equals 1. Probability must equal 1 or 100. depending if you're working in numbers or percentages. This is not in your notebook, but you do need to know this to do your homework. So let's look at another example. There are 8 different sections here. Each one must be equal in size to determine probability. If not, we should continue dividing them until they are equal in size. In this case, we want to know what the probability of 1 is. A reasonable estimate of the probability that the spinner will land on 1 is 3, what you want. 3 is what you want, over how many are possible. There's 8 possible. So probability of getting 1 is 3 out of 8. Probability of getting 2, I'm going to put squares around the 2's. How many 2's do I have? There are 3 of what I want out of 8 possible. And the last one we're going to look at is 3's. The 2 3's, 2 of what I want over 8 possible. Probability is what you want over possible. And then the other big concept is they must equal 1. So if I add these together, 3, 6, 7, 8, you get 8 eighths, which equals 1. Probably must equal 100%. And the previous slide talked about a single event happening. What's the probability of spinning a 1? What's the probability of spinning a 2? Now, if we want to find the probability of an event, sometimes we want to know the probability of spinning a 1 or a 2. In that case, again, probability is still what you want over what's possible. But if you think back, if we want a 1 or a 2, there were 3 opportunities for a 1 and 3 opportunities for a 2. So we're going to add them together over what's possible. So to get a 3 or a 2, it would be 6 over 8. Let's do some examples of that. This is example 2 in your notebook. A quiz contains 5 true or false questions. Suppose that you guess randomly on every question. I would not recommend this on a quiz, but let's suppose you do. The table below gives the probability of each score. So if you took a quiz, what is the probability of guessing 3 or more correct? Here's our notation. Probability of 3 or more correct. So correct would consist of the outcomes of 3, 4, or 5 correct. 3, 4, or 5 correct. So the probability would be 313 thousandths plus 156 thousandths plus 31 thousandths. When you add those together, you get 5 tenths, or 500 thousandths, which move the decimal point over 2, remember that, and you get 50%. So the probability of getting 3 or more correct would be 50%. This quiz contains 5 true or false questions. Same probability chart. In this case, we want to know what's the probability of guessing fewer than 2 correct. I'm going to give you a minute and see if you can do it. Probability fewer than 2 correct is going to equal which numbers? That is correct. So if you get less than 2, fewer than 2, you're going to either get 0 correct or 1 correct. Okay. 0 correct is 0.031, 31 thousandths. 1 correct is 156 thousandths. This was 0 correct. This was 1 correct. Add them together. 187 thousandths. Decimal 2 to make it into a percentage. 18.7%. So the probability of fewer than 2 correct is 18.7%. Next one. Again, this is not in your notebook, but you need to know how to do this for your math homework and quiz. In this case, this quiz contains 5 true or false questions. Suppose you guess randomly on every question. This table gives the probability of each score. In this case, I want to know what's the probability of passing the quiz. Well, passing the quiz is getting 4 or 5 correct. So 4 or 5. So how would we do this? Think about it. Okay. Our option for 4 is 156 thousandths. If we got 5, the chance of getting 5 correct is 31 thousandths. We're going to add that together. Again, it's 187 thousandths. Decimal over 2 to get a percentage. That's 18.7%. So you have an 18.7% probability of passing the quiz with a 4 or 5 correct response if you guess out of 5 questions. Last example, this one is in your notebook. You have a problem-solving application. You have 6 students that are in a race. Ken's probability of winning, is 0.2. Lee's is twice Ken's. Roy's is 1/4, likely as Lee. We have Tracy, James, and Kadeem, all the same chance. So let's create a table first. So Ken had the chance of 2/10 chance of winning. Lee had 2 times Ken's. So 2 times 2/10, which is 4/10. Roy had 1/4 of Lee's probability. So he had 1/4 of 4/10, which is 1/10 probability. Tracy, James, and Kadeem, we don't know their numbers, but they all had equal probability. So I'm just going to call them each P, because I don't know their number yet, but I'm sure we can figure it out. Do you have that filled out in your notebook? Now you'll see in step 2 that we're going to make a plan. Now, went ahead and made the equation for you. Equation because it has an equal sign, not an expression, which doesn't have an equal sign. So this is an equation. Ken, 2/10, Lee, 4/10, Roy, 1/10. Tracy, James, and Kadeem all have probability of P, or unknown P. Add these together, you get 7/10. Add these together, and we have 3 P's, 1, 2, 3. So here's our equation. Now, we have a variable, so we need to go ahead and solve the variable. Solve for the variable. We're going to subtract 7/10 from both sides. These cancel, leaving us 3P. 1 minus 7/10, that's 3/10. I'm going to add a 0 here, and then I borrowed. So I have 3P equals 3/10. I need to isolate the P, so I'm going to divide both sides by 3. Can't believe I just did that. That's a 3. Divide this side by 3. So the probability P of P happening is 1/10. So, reminder, Ken was 2/10. Lee was 4/10. Roy was 1/4 that, so he was 1/10. And then Tracy, James, and Kadeem were all P's. And we just found out that P equals 1/10. If we did this correctly, all of these added together would equal 1 whole. Their sum would equal 1 if we did this correctly. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 1.0 equals 1. So we've got enough numbers here. They're correct. Again, review. I checked them to make sure that equals 1. And you have 1. Try this problem. I want the probability that the softball team is going to win and the probability they're going to lose. Please make this both in percentages and in decimals form. I will see you in class tomorrow.